Hello, today in the coordinate geometry videos we're going to have a look at finding the gradient of a straight line or a line segment. So if you remember from our straight line video, I said that there were three ways in Core 1 that you could find the gradient of a straight line. The first way was rearranging the equation into the form y equals mx plus c, and then the m number is the gradient. The second way is what we're going to have a look at today, which is finding the gradient from two coordinates. And the third way is if you've got a curvy graph, you can find the gradient by differentiating. So what do we mean by the gradient? Well, the gradient is, if I go across 1, how far up do I need to go? So on this blue line, I go across 1 and I go up 2. So the gradient's 2. On my red line, I go across 1 and I go, well, if I go across 1, I actually go down 3. So this gradient is minus 3 because I'm going down instead of up. But it becomes a little bit harder if you're not going across 1. So looking at the green line, if I go across 1, well, I don't really know how far up I've gone. But if I go across 2, I've gone up 1. So for every 2 across, I go up 1, or if I go across 1, I'll have gone up a half. So this has gradient a half. Looking at the red line, if I go across 4, I go down 3. Well, how am I going to work out what the gradient for this is? Well, if I go across 4 and down 3, then that means to go down 3 I had to go across 4. So if I only go across 1, I'm going to do a quarter of that. So I'm going down 3/4. So the gradient of this line is minus 3/4. In general, we can say if I've got two coordinates, the gradient is equal to the change in y over the change in x. So if, say, I had two coordinates, I had x1, y1, and x2, y2. So it's looking like this. Again, I'm going to draw a picture, but it doesn't have to be accurate. This isn't to scale or anything. So here I've got my x1, y1, and here I've got my x2, y2. So the first question is, what did I have to do to go from my x1 across to my x2? Well, if my x2 was 7 and my x1 was 3, I've gone across 4. The distance I've gone is x2 minus x1. So my change in x would be x2 minus x1. And my change in y is the same thing. To work out what I need to do to go from y1 to get to y2, I just do y2 minus y1. So that gives me the change in y, which means I can rewrite the formula which we had up here. Instead of just being the change in y over the change in x, I can say it's my second y coordinate, take away my first y coordinate over my second x coordinate minus my first x coordinate. In practice, it doesn't really matter which way round you do it. You could have your first y coordinate take away your second y coordinate, provided on the bottom you have your first x coordinate take away your second x coordinate. So long as these are from the same coordinate and these are from the same coordinate, it will work. Let's have a look at how this applies to a question. So the line joining the points minus 2, 7 and minus 4p has gradient 4. So the clue here that this is about gradient is that it tells me the gradient, and we're asked to find the value of p. So we've given the gradient. We know that with the gradient there are three things it could be. It could be that I've got to rearrange the equation of the line into the form y equals mx plus c. It could be that I use my two coordinates, or it could be that I differentiate. Well, because it's a line and it's a straight line, it's not a curvy line, I can rule out differentiating. And I'd not given the equation of a line, so I can't rearrange it into the form y equals mx plus c. So that leaves me with using two coordinates, just as we've been looking at. And you can see I have my two coordinates, so it's looking good. So now I'm going to do my change in y over my change in x, and we know that's going to be equal to 4 because 4 is the gradient. So what's my change in y? Well, my change in y is p minus 7 over my change in x. Well, that's minus 4 minus, so I'm going to put minus 2 in brackets just because I know that it's very easy to make a mistake with multiple minus signs. So let's rewrite that, p minus 7 over minus 4 minus minus 2, well that becomes plus 2, so this is just minus 2 equals 4. Now I'm aiming to get p minus 7 on its own, so I'm going to multiply both sides by minus 2, which gives me p minus 7 equals minus 8. So now I can see that p is going to be equal to, add 7 to both sides, I get minus 1. Okay, let's have a look at this second question. So the points A and B have coordinates minus 5, minus 2 and 3, 1 respectively. Find the equation for line AB, giving your answer in the form AX plus BY plus C equals 0. I'm going to add to this because so often when we're asked for it in this form, we're asked to have A, B and C as being integers. I'm going to find it with integer values as well. So let's have a look at what this question's asking us about. We have two coordinates. We're asked for the equation of a straight line going through the coordinates. So my straight line is going to have the same gradient as the line section connecting my two coordinates. So when we're looking for the equation for line, I can get the gradient from my two coordinates, and I can take one of my coordinates to use in my equation. So again, when I'm trying to find the equation of a line, there are two things that I need. I need a coordinate on the line, and I need the gradient of the line. Well, I've got two coordinates which are on the line, so I'm okay for that. The other thing which I need is the gradient of the line. So again, there are three ways that I could find the gradient. It's not going to be y equals mx plus c because I don't have an equation to rearrange into that form. It's not going to be differentiation because we're looking at the equation of a line. It tells us that here. So it must be using the two coordinates to find the gradient. So again, I'm going to say the change in y over the change in x. Well, that's equal to my second y value minus my first y value over my second x value minus my first x value. Being really careful with our minus signs, I get 1 plus 2 is 3. I get 3 plus 5 is 8. So I get that the gradient is 3/8. Now I've got the gradient, I can use my equation for my line y minus y1 equals mx minus x1. I can substitute in, it doesn't matter which coordinate I use, so I'm going to go for 3, 1 because it's an easier coordinate. I'm going to say y minus 1 equals my gradient, well that's 3/8, x minus 3. Again, because I want to get this all in terms of integers, I'm going to get rid of the fraction at this stage. So I'm going to multiply everything through by 8. So that gives me 8y minus 8 equals 3x minus 3. And now I just expand my brackets. That gives me 8y minus 8 equals 3x minus 9. And then I just bring everything to the same side. So I'm going to end up with minus 3x plus 8y. Now minus 8 plus 9 becomes plus 1 equals 0. So I now have all my integer values. There are going to be multiple different answers for this. Just so long as you can multiply everything by a constant and get my minus 3x plus 8y plus 1, you will have got the right method. So just to recap, we know that the gradient is equal to the change in y over the change in x. And if we've got two coordinates, I can do the y coordinate take away the other y coordinate over the x coordinate, take away the x coordinate. I've just got to remember that these are the same coordinates. So these come from the same coordinates and these come from the same coordinates. I hope that's helped you with the gradient. Check back for more coordinate geometry videos.